Hey, my name is Joel, and I've been a programmer for a First Tech Challenge team for the past 6 years. And over the past 6 years, I have learned something very valuable about programming. It's how to be lazy. You see, being lazy is absolutely key to programming because usually hardware gives you the robot like a week before competition, and if you're not ready and don't have a good architecture in place to program it with, you're kind of cooked. So the way I've been able to program a robots in like a couple weeks time is with a command-based architecture. A command-based architecture makes it super easy to code autonomous routes, teleops, all in a very nice, easy to understand syntax, and the logic is incredibly simplified by it. So in this series, I'm going to be showing you how to make your own command-based architecture and also the benefits of it. And finally, we're going to integrate all of this into an example robot and just see how everything works together. So without further ado, let's get into the benefits of command-based architecture. So this is just a video of our autonomous routes, and this just goes to show you how capable a command-based architecture can be. Keep in mind, this was coded in like a day or two, and so it's not the best autonomous route in the world, mainly just because we didn't have time to optimize it and really make it consistent. But this goes to show you how awesome it is to have a lazy programming architecture like command-based, because you can make stuff like this very quickly. Alright, so let's get into the benefits of command-based architecture. So first of all, let's define a command-based architecture. A command-based architecture is basically a structured programming paradigm used in FTC and FRC, and it breaks robot functionality into commands, which are specific actions, and subsystems, which are robot components, and then it uses a scheduler to manage all of those things together. And so what this allows you to do basically is it allows you to basically have a very organized structure that where everything can work together in parallel, everything is updating, and also your loop times are very optimized so you don't have any unnecessary reads or writes going on, and it's all just very nice. So first of all, the modularity in code organization is key for command-based. Commands encapsulate individual actions like driving, lifting, shooting all together into one spot. And so you can have an action that says like drive to the chamber and score a specimen, and that would be a totally feasible action, feasible command you could have. And then your subsystems are the ones that manage your hardware components, which makes debugging easier. So all your subsystems have to do is basically say, tell the motor to go to this point, and that's basically it. You can have like predefined positions if you want, but this is literally it. Is just hardware components telling your subsystem what to do, and really just position control. And so then you have reusability and scalability. Commands can be reused across different modes, autonomous and teleop. That means that if you want to say drive to the chamber and score a specimen, you can do that without having to do a bunch of complicated logic. You can literally interrupt your drive sequence with your driver that your drivers are commanding, and then command your drivetrain to go do an autonomous action. And so that's super cool. So command groups also allow for complex sequence of options. We just talked about that, how you can basically do anything in these command groups and combine commands into complex actions. You're not limited to just one command at a time. You can do multiple commands in parallel actions, sequential command groups, and everything. So one thing I love about command-based is how easy it is to read. Like here, let me just show you guys our autonomous real quick. So this is our specimen side route, and as you can see, this is all it is. You don't even have a loop function, you don't even have an initialize function. We have a set alliance function, but you don't really even need that all the time. All it is an initialization function where it schedules all your actions, and you have your parallel command groups, you have your sequential command groups, which is basically all of this to the end, and then you have your run commands, which update everything. And that keeps everything in this nice, concise, easy to format and read syntax. Alright, so back to there. So each subsystem just contains functions and periodic methods that happen every loop. So for us, it's read, loop, and write. There's also a periodic method built into the FTC library, but I would recommend making your own read, loop, and write functions. For basically what that allows you to do is you can ensure that read and write are never happening at the same time, and it also means that basically your logic follows a very nice structure. So you have your read function up here, and then you take those inputs, you compute your logic, then you tell your subsystems what to do with that logic, and then you write that to your hardware. And so that makes for a very nice optimized loop times, so that way all of this takes place. All your logic takes place at once, all your writing takes place at once, and all your reading takes place at once. And that usually keeps your loop times around 100 loops per second. One thing that I've really come to understand about the benefits of command base is that they're super easy for new programmers to understand and contribute with. If you have a good Java background, that helps a lot, but we've been able to basically have our new programmers make actions and commands for us. So even if their code is hard to understand for them, it is hard to understand to other people and people not working on their subsystems, we just have to use the commands. So if you can understand what the command does, then that means you can effectively use other people's code, and that is so helpful. So the best part about command base is state management and parallel execution. Everything is done in parallel. You don't have to worry about your drivetrain not updating. You don't have to worry about making stupid while loops. Everything just happens at the same time. So for example, a shooter can spin up while the turret aligns, a drivetrain can drive while an arm raises. So you don't have to wait on all that stuff. It's all done in parallel, and it's very nice. It also simplifies asynchronous controls, so it eliminates manual loops and timers. The event-driven execution, so basically the way a command knows how to go from one command to another is you have an is-finished statement. So every time when a command is finished, it will return true when it's finished. And so that allows commands to complete based on sensor feedback. So an example of that is a command can end automatically when a limit switch is triggered. So like if you have a lift reset command, that can just finish once a limit switch is done. Another one that's super big, and I've learned a lot about this recently, is built-in safety and interrupt handling. And basically what that does is if a new command is scheduled, the default command or run command you can also say you can interrupt it with whatever. You can interrupt it automatically, and that's super helpful. You can also prevent multiple parts of the code from conflicting over the same subsystem. So an example is that a manual lift command stops if an autonomous lift sequence begins. So say your drivers won't have manual control, you could also just have an autonomous sequence that interrupts the default manual control, which is super cool. And then we've talked about this already, but you can also have smooth transitions between autonomous and teleop modes. So even if your autonomous sequences, like your drive sequences is my favorite thing, is that you can use them in both autonomous and teleop, and that can be super powerful. So, and drivers can trigger pre-programmed actions during teleop using button bindings. So yeah, we've already talked about this a lot. Stronger collaboration is huge with command based. Multiple programmers can just work on their own subsystem independently, and code changes remain localized, which reduces your conflicts. So instead of the whole autonomous route changing at once, you just change your subsystems, and that won't affect the other subsystems, and all of your autonomous op modes and stuff will stay the same. It's also easier to review and merge code within a team. So if you're using Git, for example, this is just such a relief. If you're all working on the same file, the merge conflicts with Git are atrocious, and yeah, you don't want that. So if you're wondering what on earth does this even mean, like, let's just take a look at syntax with command base and syntax without command base. And basically what I'm trying to do here is just show y'all how this works under the hood, so y'all can basically get a basic understanding of command based. So this is here's a case study with our command based. This is just a action that that tells the robot to go score a specimen at the chamber. So we have a point-to-point command, we set our point, we go to the chamber, we drive to point, we score the specimen, and we have a wait command. And that's it. It's literally like 5 lines of code plus our updates. It's so easy. So then you go to the traditional syntax, and this is doing the same thing. And to be clear, this is not bad. In fact, you can actually make more capable autonomous routes with this syntax. For example, Wolfpack back in PowerPlay had some insane autonomous routes with multiple different state variations, and they could detect failures all along their route and basically change it along the way. And that you can do that with this type of architecture, but you can do a lot of the same things with commands too. You just have to keep that localized within your subsystem. It's a bit harder to do, but you can still do this with you can still do a lot of this with command based. But as you can see, instead of the 5 lines of code, we now have like upwards of 3 times the amount of code we have to write. We have this Java syntax, which might not be so familiar with new programmers. It's not as easy to understand, and it's just kind of a pain in general. So this is really nice, but I prefer command based all day, every day. And so that's all I had for you guys. I hope this helps you understand how powerful command-based architectures can be, and I hope this helps y'all out in your programming journeys. Next video, we'll discuss making our first code, which will be our robot class and our robot hardware class, which will manage all our bulk caching, and I will see you in that video.